This is the first lesson over vectors, and we're going to focus just on the basics of vectors today. So our target by the end of this video is to be able to explain what a vector is and what are the basic definitions and operations that are related to vectors. Okay, so let's start with the first question, the basic question. What is a vector? A vector is used a lot in physics to represent quantities like force or velocity. Things that involve both length and direction. So it's a directed line segment. On the graph, it's going to look like a ray where you've got an endpoint and an arrow at one end, but it doesn't keep going forever. Okay, so a vector has direction and distance. So in this picture, notice R is our starting point, that's our initial point, or the tail, and then P is our ending point or our terminal point, okay, which is also called the tip. Okay, so this would be called vector RP. The terminal or the initial has to go first, the terminal is second. Okay, so sometimes it will look like a ray in geometry, or you can use a lowercase bold letter, which is what you'll see more often in your textbook, such as the V, the little V in the picture. Okay, so the arrow again does not mean it continues forever. It just indicates what direction the vector was moving and the terminal point. Okay, now here are some vocabulary terms and formulas. You may need to pause the video while you get this written down. When we talk about the components of a vector, it's an ordered pair that's used to represent the vector. But we do not put it in parentheses because parentheses would just be a point. So if I want to tell the difference between a vector and a point, I'm going to use what's called chevrons. They look like pointed parentheses. Okay, so when you see the chevrons with two coordinates inside, that's telling you the horizontal and vertical components of your vector. Okay, to find the components of a vector, we're going to take the terminal point and the initial point, and we're going to subtract the x-coordinates and the y-coordinates. So your formula to find the vector is terminal minus initial on the x-coordinates and terminal minus initial on the y-coordinates. x2 minus x1 to get the horizontal component, y2 minus y1 to get the vertical component. Magnitude is just another word for length. It's another way to say length or distance. Okay, and magnitude is usually denoted by, it looks like a double absolute value sign around the vector. And the formula, it's like using the distance formula, but one of your points would be 0, 0. So the formula is the square root of your first component squared plus your second component squared. Okay. Okay, now the components of a vector are like taking a vector from anywhere on the graph and moving it so that your initial point is at 0, 0. So the components tell you if I started at 0, 0, where would I end up? What would be my terminal point? Okay, for example, let's say we have an initial point at 111 and a terminal point at 93. And notice these are in parentheses, which tells you that it's a point, not a vector. We want to find the components of the vector, and then we're going to find the magnitude. So to find the components for vector v, I'm going to take my terminal point x-coordinate and my initial point x-coordinate and subtract them. And then I'm going to do the same thing for my y-coordinates. And remember, it's terminal minus initial. You might write that down, terminal minus initial. So when I simplify that, I'm going to get components of 8 and negative 8. Okay, now to find the magnitude of vector v, or the length of the vector, my formula is to take the square root of the initial or the horizontal component squared plus the vertical component squared. Okay, so 8 squared is 64. Negative 8 squared is also 64. When I add that together, I get the square root of 128. And then I'm going to simplify it, and when you break it down, you should come out with 8 square root of 2. If you don't know how to break that down, put a question mark beside it, and you can ask me in class tomorrow. Okay, so the length of the vector would be 8 times the square root of 2. Okay. Now, there are some vector operations that we're going to talk about today, namely addition, scalar multiplication, and subtraction. Okay, so adding vectors and subtracting vectors is very straightforward, very simple. If I want to add vector u and vector v, then I'm going to take my horizontal components, -2 and 3, and add those together to get my new component. And I'm going to do the same thing for the verticals, the ones that are in the y position. So 5 plus 4. Okay, and when I simplify that out, I'm going to get 1 and 9 as the components for my new vector. That's the addition. I'll show you graphically what that means in just a minute. Okay, number 2 just says -5 times u, vector u. The -5 is called a scalar. It's a number. It is not a vector, so they're not components. It's just a number, and it's like distributing. Okay, so we're going to say -5 times each component of u. So that would be -5 times -2 for the first component, and -5 times 5 to get the second component. And that would give us an answer of +10 and -25. So scalar multiple just means you distribute that scalar to both components. Okay, now number 3, we've got two different things going on. We've got subtraction and we've got a scalar to multiply by. So let's do the scalar first, 2 times u. Okay, so if I do 2 times the components for u, 2 times -2 is -4, 2 times 5 is 10, and then I'm going to subtract that from vector v, which has components of 3, 4. And on subtraction, just like addition, I'm going to subtract the horizontal components and the verticals. So I'm going to say 3 minus -4 for the first component, and 4 minus 10 for the second component, which would give us 7 and -6 for an answer. Okay, so when you're adding, subtracting, you keep the components separate, the horizontals with the horizontals, the verticals with the verticals. Scalar multiplication is like distribution. Okay, now I want you to pause the video and try these 3 problems on your own, and we will work them out in just a minute, but pause it to try it, take as long as you need, and then start the video again. Okay, v minus w would be 2 minus -6 for the first component, and 3 minus -2. And when you complete the subtraction, you will end up with an answer of 8 and 5 for your components. Okay, on number 2, if you'll take care of the scalars first, 2 times v would be 2 times 2 or 4, and 2 times 3, which is 6. And then 3 times w, 3 times -6 is -18. 3 times -2 is -6. And now we're going to add those two together. So 4 plus -18 would be -14. And then 6 plus -6 would give us 0. So the answer would be -14 and 0 for your components. Okay, and then for w plus v, -6 plus 2 and -2 plus 3 for your components. So we would end up with an answer of -4 and 1. Be sure that you've corrected what you did not get right when you tried it on your own. Put a question mark beside it if there's anything you still do not understand. Okay, now what's really happening when we're adding vectors? Okay, there are two different methods of showing it graphically. One is called the tail to tip method, and then the parallelogram method. So let's look at this tail to tip method. Okay, so one way to show vector addition is to start out and to graph your first vector. So if we're doing u plus v, we want to graph u from the origin to wherever the components end up. So in this case, u is 1, 3. So I would start at the origin, and I graph the point 1, 3. That's where I terminate. Okay. Then I take the next vector and I start from where the first vector ended. So if my v is 4, 1, I'm going to start from the tail end of this vector. I'm going to put the tail of the second one by the tip of the first one. And I'm just going to go 4 to the right and 1 up. And that's how I get vector v. Now, that dotted line, that red dotted line, is called the resultant vector. It's what results from the original starting place to the final terminal place. Okay, so the dotted line represents what we actually get when we add together. So from 0, 0 out to this point, the point that I'm ending on is 5, 4. And if you take those two vectors and add them together, you should get 5, 4. 1 plus 4, 3 plus 1. Another way to do it graphically is called the parallelogram method. And this time, instead of putting one vector at the tail end of the other, we're going to draw them both from standard position from the origin. And then we're going to create a parallelogram. Okay, so you can see where they put in the extra u and v vectors, and where the corner of that parallelogram is, the diagonal of that parallelogram, is the resultant, which is the same line that we had drawn in the tail to tip method. Okay? So that's what's really happening when you're adding vectors. If you have to sketch something that has scalar multiples, okay, then what the scalar does is it changes the length of your vector. So if I'm multiplying by 5, that means I'm making my vector 5 times longer. So it's like taking 5 vectors and putting them tip to tail. Okay, same direction on every one of them, but it's like taking 5 of those vectors and stacking them. If there's a negative, it changes the direction. Okay, so instead of moving up and to the right, it would move down and to the left. Okay, one last thing that we need to cover in this section is called a unit vector. A unit vector is a vector that goes in the same direction as the vector you're given, but instead of a length of 5 or 7 or whatever the length is, we want the length to be 1. Okay, so a unit vector is a vector of 1 unit length. Okay, to find a unit vector, there is a formula. And what we're going to do to make the length be 1 instead of whatever it is originally is we're going to find out what that length is, what the magnitude is, and then we're going to divide each component by that magnitude. So the vector formula looks like 1 divided by the magnitude times vector v. So we're going to use that as the scalar. 1 divided by the magnitude is our scalar, and we're going to distribute that to each component. So here's an example. If vector v is -2, 5, the first thing I need to do is find the magnitude of v, which again is the square root. Remember, magnitude is distance, so it looks like a distance formula. First component squared plus second component squared. -2 squared is 4. 5 squared is 25. So when I add that together, I get square root of 29. And I can't really simplify that. Okay, so to find my unit vector, I'm going to say my scalar is 1 over the square root of 29, 1 divided by the magnitude. This is how I get the length to be from whatever it is to a smaller length of 1. I'm going to multiply that times the coordinates. Okay, so when I distribute that, I end up with -2 over the square root of 29 and 5 over the square root of 29. That would be my unit vector, and if I found the length of the new vector that I just wrote, the unit vector, it should come out to be 1. So if I did the square root of each of those components squared, it would add up to 1. So unit vector, it would go the same direction as our original vector. If we graphed -2, 5, the only difference is its length would be 1. Okay. If you're checking in the back of the book on some of your assignments, they will probably rationalize the denominators. So another way to write that answer out would be -2 square root of 29 over 29 and 5 square roots of 29 over 29. But For our purposes, you do not need to rationalize. Okay, keep in mind again that chevrons are used for vector components to distinguish it from just a point on a graph. Okay, and if you will be sure to summarize what we just did in these notes, okay, all of the different pieces of the notes.